This video takes a look at multiple linear regression using the SPC for Excel software package. And this is one of the techniques under our cause and effect panel on the SPC for Excel ribbon. But essentially what regression analysis does is it takes a look at a response variable. In this case, we're going to look at delivery time and says, are there some variables that have a direct impact on delivery time? We're going to use some data from Douglas Montgomery's book, Introduction to Regression Analysis, excellent book. But anyway, in this book, they are looking at delivery time, and they think that the number of cases a delivery driver has plus the distance he has to walk impacts delivery time. So they've gone out and they've collected data for 25 deliveries. For example, in the first delivery, it was 7 cases, 560 feet, and took 16.68 minutes. So what they do is they have their data, and we're ready to analyze it after you enter it into an Excel spreadsheet as shown here. You begin by selecting the data, and we can use our utilities, select cell to do that. Makes it easier when you start up. And then we go to regression on the SPC for Excel ribbon and select that, and we get our input box. Well, it is assumed that the response variable, in this case delivery time, the Y variable, is in the last column, and it assumes that the independent variables or independent factors are in the previous column. So since there are two, we're only going to be using two independent factors here, number of cases and distance. And we select OK, and we quickly get our analysis of results. The output for the regression analysis is placed into a new workbook, and there are four data sheets in that workbook. One is the data. It just gives you the data that you had originally. It gives you observation number of cases, the distance, and the delivery time. And this is the original regression summary. What you have is you have your ANOVA table for the model with degrees of freedom, sum of squares, mean squares, F value, but the key one is the P value. And if it's less than 0.05, it's significant. And if that's the case, it'll be turned red. So this model is significant. Then down here we have our information for the variables, the intercept, number of cases, and the distance. We have the coefficient, the standard error, the t-statistic, and then the p-value, which says, is it significant? And you can see that all three of these are significant. And we have upper lower confidence limits on the coefficient. And we also have the variance inflation factor and the standardized coefficient. This allows you to see which one has more of effect. The larger the value, the larger the effect. And then we have our regression statistics. We have R squared, which is a measure of the overall fit, how much variation is explained by the model. And here you see about 96% is explained by the model, very good. And it gives your adjusted R squared, the mean, all the way down to press, and your R squared prediction. Then we have a page of residual data. And what this is it gives you the residual analysis, so you can have insights if your data has any outliers. We have our observation number, the observed value, and then we also have just the raw residuals, leveraged, standardized residuals, the internally studentized and externally studentized residuals, DFITs, Cook's distance, and the standard error of the estimated mean, along with the confidence limits on those. And you can see the point number 9 has a number of red things which suggest it may be an outlier. Point 22 has a few as well. And then we have our residual plots. This first plot is simply the plot of as a normal probability plot of the residuals, the z-value over here, residuals here, should fall fairly close along a straight line if it's a good fit. There are a number of other charts you have. You can select what type of residual you want to have. You can have the normal plot of the residual versus the type of residual that you want. You can have residual versus predicted result, again selecting the type of residuals you want. Residuals versus observation number, and we'll just take this one versus the standardized residuals. We select OK, and you can see then you get a plot of the standardized residual versus the actual run number. We also have some other charts to look at. You have leverage versus observation number, Cook's distance versus option number, and a good one, predicted value versus actual values. You select OK, and this gives you the predicted versus the actual values for the data. You can also revise the regression analysis. You go back to the original regression summary. What you'll see is a revise button here. And what this does, it allows you to have some choices. You can remove variables. For example, you can remove either the number of cases or distance if one of them is not significant and rerun the analysis. You can also remove observations. come up, and you can see that observation 9 could be out. We could remove that and rerun the analysis. And you also have you can transform the y values to something else. In this case, oops, wrong one. In this case, we would be looking at transforming the y values using a square root, arcsine, ln, reciprocal square root, a reciprocal, or doing a Box-Cox transformation. It allows you to revise the data. Anytime you have removed data and data has changed, it's put into a new workbook. So this gives you a quick view of the regression analysis in the SPC for Excel software.